goal for today is to be able to solve and graph linear inequalities. So we are going to be isolating variables that I think you guys have solid. You guys know how to isolate variables. You guys, for the most part, know when to switch the inequality symbol. If not, we'll remind you today. The only two new things that you're learning, and you might have learned it before, is whether the lines will be dashed or solid or shaded above and below. So we will talk about that. I'm recording right now. I'll put it in the slideshow later on, so you can rewatch it if you want, or there's other helpful videos that you can check out as well in the slides. Your practice is going to be the worksheet that you picked up that says evens or odds. You also picked up your test review, so I always like to give you that as soon as I have it ready. Use it to see how well you're doing. I'll put the key up in the next few days, and you can check your answers to it and all that good stuff. The practice, though, I will probably check tomorrow as long as I'm here. I mean, I plan to be here, unless I have to take my dog to the vet. You'll know because I won't be here if I'm doing that. Otherwise, I'll check it the next day. So either way, if I'm not here, that's what you're working on. You might have to look up how to do one or two of the problems, but that's not a difficult task. So, and you guys have Miss Turan, so I expect it to be finished if I'm not here. But I do plan to be here, so if I am here, we're taking an exit ticket tomorrow. If I'm not, we'll take it Wednesday. And that's just 3 questions on this lesson, and that will be the one assessment for the week. So it's the expectation that you're assessed at least once a week. That'll be the one assessment. And then just, finishing up topic for all the lessons for that this week. So the good thing about coming back from Thanksgiving break is that there's only 3 weeks left in the semester. So that's a good thing for most of you. I think there's only 5 or 6 Fs in this class. So it might be a bad thing for those 5 or 6 of you. Luckily, there are still ways that you can work toward getting your grade up. I've been saying it all semester. You could come to tutoring Fridays. There's only 2 tutoring sessions left. So this Friday and next Friday, I'm not having tutoring the last day of school. They kick you out right after your last class. So just be aware of that. So this week and next week are the last 2 tutoring sessions. You can also ask to do corrections or retake something as long as I'm not teaching. So if we're just working on homework in class, you can choose to take a test instead. It's worth more points anyway, so I'd probably rather you can take something in class instead. There are some test corrections that you can do at home too, so just speak up. If you're not doing it by now, then I assume you don't really care to do it. So that's all on you to get your grade up. What else? The other big thing this week is that the deadline for late work from the purple folders is this Friday. I thought about extending it, but honestly, it's the end of the semester. I know that if I extend it, you guys will just put it off even longer, and then you're more likely to not do it. So I'm going to hold true to that deadline that's been posted for weeks now for the purple folders. Tomorrow or the next day, I'll give you a missing assignment report so you know what exactly falls under that deadline, and then I'm not accepting it beyond that. All right. The topic for test dates, you can see on the board over there when we're testing, and you can see it on the screen. So like I said, it's just this week, next week, then finals week. We're not retaking any tests finals week. There's just no way. We have to review for finals, and then you take your finals. That's what we're doing. So the topic for a test is really just all next week. We're reviewing Monday, you're taking the computer test Tuesday, and that's the one that you get to use notes on. And for this unit, I imagine that the computer test is going to be a higher score than the paper test, just because it's this unit. So normally it's the other way around, but that's just what I've seen in the past. So try your best for Tuesday. Don't just brush it off because you know we're gonna retake it on Friday. All right, but if you do that on Tuesday, we are retaking it Friday, you just can't use your notes. And it is on paper. So any questions about that? All right, and that's really like your last chance to retake that topic 4 test. So if you're not here, then you just don't get to retake it. All right, so some vocab. First, we have linear inequality. So we have linear inequalities, which are in the form y equals mx plus b. Except the equal sign is now an inequality symbol. Brian, Jason, sit up. All right, so linear inequalities are in the form y equals mx plus b, except the equal sign is now an inequality symbol. So now it's y less than mx plus b, or y greater than mx plus b, and the other symbols too. All right, the solution to a linear inequality is going to be all the coordinates What are coordinates? What do they look like?
X, Y,
Good. So in parentheses with a comma. So all the coordinates that make the inequality true. All right, a solution to a linear inequality is all the coordinates that make the inequality true. Linear inequalities are in the form y equals mx plus b, but the equal sign is now an inequality. All right, so questions on the vocabulary. I think it makes more sense once we start going through them. So first, we're going to determine if these ordered pairs or these coordinates are solutions to this linear inequality. You could do it algebraically, which we're going to do right now, or by graphing. You can see which one you like better. But look at the linear inequality. It's not in slope-intercept form. What form is it in?
Or in the.
It is not in that one. It is in standard form. Normally we rearrange it to slope-intercept form, but you guys know by now that you can do that from standard form to slope-intercept form. So you guys will do that a little bit later. Right now, we just need to check if these coordinates would make the inequality true. And if it is true, then it's a solution. So plug it in. So remember, this is x, this is y. And then I have 2x, which what are we saying that x is?
2.
Good. Minus 3y. And what are we saying that y is?
5.
Good. Less than 15. So when I simplify this, if it's less than 15, then it is a solution. So what's 2 times 2?
4.
What's negative 3 times 5?
Negative 15.
Good. Bring down the less than 15 part. What's 4 minus 15?
9.
Negative
9.
Negative 11.
Negative 11.
Whoops.
Less than 15.
Yes, it's true.
Now, is negative 11 less than 15?
Yes.
So then, yes, the coordinate 2, 5 is a solution to that inequality. Does that make sense?
Yes.
All right. But just like normal inequalities, there can be multiple answers. It's not just one solution like the equation. So try the next one.
Okay.
We have 2 times what this time?
Negative.
Good. Minus 3y, which what's y this time?
Negative 7.
Good. Less than 15. I write really big, so just try to keep it in this box. But what's 2 times negative 1?
Negative those.
And negative 2 times negative 7.
Negative, oh no,
Negative,
positive 21.
Positive.
Good, so put plus 21 since it's positive. Bring down less than 15. What's negative 2 plus 21? 19 less than 15. Is that true?
No.
So is this one a solution?
No.
No. Questions about that process? All right, so that's a good way, like if on a test, if it's just asking about 1 or 2 coordinates, then you can do it this way. Try these next 2 on your own and we'll see if you do it right. So 3 negative 4, when you plug it in, 2 times 3 is 6, negative 3 times negative 4 is a positive 12. So 6 plus 12 is 18. 18 is not less than 15.
Okay.
And then 0, 0, when you plugged it in, is it a solution?
Yes.
Yes, that one was a little easier because 2 times 0, 0, 3 times 0, 0, 0 is less than 15. So yes, it does work out. Questions about that process? Make sense? All right, so again, that's helpful if it's just 1 or 2 coordinates that you need to check. But if it's a lot of coordinates that you need to check, maybe it might be better to graph it. So I'll show you how to graph it. And so fill in these blanks. All right, fill in these blanks. Don't do the example. We'll do the example together. But first, you're going to want to make sure that the inequality is in slope-intercept form. So what would that look like?
21.
Good. Except of course now the equal signs and inequality symbols, which would be like any one of these 4. And then there are certain times that you need to flip the inequality symbol. So when do you do that? When you, good. So star it, highlight it, it's reminding you right there. Luckily on the exit ticket and on Tuesday's topic board test next week, you do get to use your notes. So you can just have this little cheat sheet handy. Otherwise, you'll have to commit this to memory if you're wanting to do better on your retake next Friday. All right, so be aware. You flip the inequality symbol when you multiply or divide a negative on each side of the symbol. All right, not just in general if you're multiplying or dividing a negative. It has to be done on each side, like your inverse operations. All right. Then once it's in slope-intercept form, you can graph it. So put a dot on your y-intercept. Use your slope to find your next dot. To draw the line through it though, you have 2 options now. It's either going to be solid or dotted. I usually say dash, whatever. For the solid lines, it's for these 2 symbols. Less than or equal to or greater than or equal to. All right, an easy way to remember that is that when we would graph equations, the stuff with an equal sign, didn't we always use a solid line?
Yeah.
Yes, so the equal sign is partially in these symbols, right? So you would use a solid line for that one too. Anything on the line is a solution. The dotted lines are the ones without the line underneath. So less than or greater than. That's one of the things you need to pay attention to now. The last thing is where it's shaded. Because anywhere that it's shaded is a solution. So you need to know whether to shade above or below. So you shade above when it's y greater than or y greater than or equal to. So put that y in there so you know. And then you shade it below when it's y less than or y less than or equal to. And I'll show you like an easier way that you can try and remember that. Otherwise, just use your cheat sheet. Don't put the example in yet. We're going to do that together. Make sure you have all the blanks filled. All right, so example. Flipping to the other one now. Notice it's the same one that we had up here when we did it algebraically. Now we're graphing it. So is it in the correct form?
No.
No.
No. To get it into slope-intercept form, what variable do we need to isolate?
3y.
The y. All right, how start with what's farther away. How do you cancel out the 2x?
Subtract it.
Add it.
Subtracting it would make it cancel out. 2x minus 2x is 0. I have negative 3y. Do I need to flip the sign when I subtract?
No.
Yeah.
Not when you subtract. On the right side, are these like terms?
Yeah, no.
So you just rewrite them next to each other. How should you rewrite them?
Negative 2x plus 15.
Good. And we do it that way so that it looks more like y equals mx plus b. Just don't change the signs. So the x term is still negative, the 15 is still positive. Questions about that? All right, how do you get the y completely by itself?
Add 3.
That wouldn't cancel it out.
Add 3y.
What's it doing to the y right now? Negative 3 times y.
Yeah.
So opposite would be
Divide.
good. So do that on each side of the symbol. Don't forget you have to do it to both terms on the other side. It cancels out over here. Do I need to flip the sign when I divide by a negative?
No.
No. Yes.
Yes.
Yes, if you look back at your steps on your cheat sheet, that was one of the things it told you when you multiply or divide a negative. So go back. I'll highlight it for you so you can see. But now instead of less than, it needs to be greater than. What is my slope going to be?
Negative 5.
Can it be a fraction?
Yes. So negative 2 over negative 3.
Can I simplify that fraction?
No. No.
You shouldn't have a double negative in your
Yes.
fractions. So a double negative would make a positive. So it can be a fraction, it just needs to be a simplified fraction. That's my slope. What's my y-intercept?
Negative 5.
Good. Questions, comments? All right, so now that it's in slope-intercept form, we can graph it. So like we said, the y-intercept's negative 5, so put a dot there. And then my rise is 2, my run is 3. So since it's positive, am I going up or down 2?
Up 2.
Up 2, and then always to the right 3, unless you're working backwards. That's really all that we can plot on that graph. And how do I know whether it's a solid line or a dashed line?
If it's
Because it's no equal to.
Good. So you look at the symbol, since there's no line underneath, no equal to, is it solid or dashed?
dash. Dash. Solid.
Dashed.
Oh, over.
And put your dashed line to connect the dots. And since it's y greater than, is it shaded above or below?
Yeah, above.
Above. So it's pretty easy to see which way is above here. Sometimes it does get confusing. So what I usually think of is you want y to be greater than the line. So you're gonna highlight where y is bigger than the line. So like bigger than the y-intercept. Does that make sense?
By the time he gets back, we're out of time.
Maybe a little later on. I just choose to do it that way instead of memorizing random symbols. You want to memorize random symbols? Go ahead. All right, but I just know it's y greater than, so the y values should be greater than the line. Does that make sense? All right, and then if you look back at these coordinates that we tested to see if they were solutions or not, they do match up with the graph, and maybe you'll find it easier to tell me if it's a solution or not by looking at the graph. Like 2, 5. Is 2, 5 in the shaded area? It'd be right here. So then yes, it's a solution if it's in the shaded area. What about 0, 0?
It's
Right
a
here.
Solution.
Good. What about -1, -7?
Solution. No, not solution.
It would be like down here. If I made the graph bigger, see that it's below, which is not where the shaded area is.
Oh, okay, so the points that are in the shaded areas are solutions.
Yes.
Okay.
So like all of this right here, any point that you pick, these are all solutions. Questions, comments? All right, so then a few more examples. Everyone do me a favor and sit up. All right, so number 1. All right, if you can't sit up, then I'm gonna take away your desk. You can stand at the back table with this chair. All right, so number 1, is it in slope intercept form?
No. Wait. Yes.
Yes, it looks like y equals mx plus b. So go ahead and graph it. What is my y-intercept? -5. So plot it 5 under the origin. So right here. And what is my slope?
1/3. 1/3.
So I'm going up 1 to the right,
3.
up 1 to the right,
3.
and keep going.
Oh, okay.
And you can probably make a straight line out of this. If you need to work backwards, then do the complete opposite. So go down 1 to the left 3. Down 1 to the left 3. Either way, you should be making a straight line. How do you know if the symbol tells you if it's dashed or solid? It doesn't have that equal to part in it. So is it dashed or solid?
Dash.
Dash.
Good. So connect it with the dashed line. And is it shaded above or below?
Above.
Above. All right. So then lightly shade it with your pencil above the line. Those are all solutions. All right, questions? All right. So try number 2 then, and then I'll project it in about. So your line, well, first, is it in slope intercept form? Yes or no?
Yes.
Yes, so you should not have had to do any rearranging. You should have just been able to graph it right away. What's your y-intercept? -1. So your first dot should have gone at where y is -1. And then use your slope to find your next point. Since it's negative, do I go up or down?
Go.
down to, and always to the right, whatever your run is, unless you have to work backwards. All right, but this is the line you get. It's solid because why?
It's going, oh, because it has a,
It has the line underneath. Anytime it's equal, whether it's an equation or an inequality, it has that equal to part, solid line. And then since it's y less than or equal to, it's shaded below. All right, so where the y values would be lower than the line, so lower than -1 down here. Does that make sense? Any questions?
No.
All right, we have time for one more, one of the rearranging ones, so don't pack up yet. All right, look at number 3. Is it in slope-intercept form?
no,
What's the first step in getting it there?
isolating the y.
By subtract 5x on each side.
Okay.
And then I get -2y. Do I need to flip the sign right now? Not yet. And then on the right side, what do I end up with? -5x plus 12. How do you get y by itself?
Divide -2y, or divide -2 on all sides.
Good.
Yeah.
Do I need to flip the sign when I divide a negative?
Yeah.
So flip the sign. It's now less than. What's my slope? Can my slope be a fraction?
Yes,
It just needs to be a simplified fraction. Should I have a double negative?
no, 5/2.
So it should be a positive 5/2x. And what's my y-intercept? That should be a -2, not a, sorry. What's 12 divided by -2?
-6. Good job.
And now that it's in slope-intercept form, can I graph it?
Yes.
So practice graphing that one.
Yes.
Also notice the sign change, all right, because we divided a negative on the side.
No, bro.
That's not how you said it.